right, we're going to talk about compound interest. So here's a definition for you guys to put into your notes. Compound interest is an exponential model that is used to calculate the value of an investment when interest is compounded. So what we're talking about is we're investing in some way, we're earning interest on our investment, and compounded means that we are calculating the interest a certain number of times in a year, and that's different depending on how you have invested your money. So it has a formula that we need to write in. The formula is A equals P times 1 plus R over N raised to the NT power. So P in that formula is the initial principal invested. That's going to be a dollar amount. That is how much money are you investing. R is the annual interest rate. This will be a percentage in the problem, and you are going to write it as a decimal for using the formula. N is the number of compounding periods per year. And then, let's see, T is number of years. I'm running out of room. And A, what is the whole thing for? The whole thing is the value of the account after T years. All right, so let's see how this formula gets used, what kind of example we would apply this formula in. Example 2, Tamira invests $5,000 in an account that pays 4% annual interest. How much will there be in the account after 3 years if the interest rate is compounded annually, semi-annually, quarterly, or monthly? Okay, so in this example, why don't we define what our variables will be, what we're going to plug in. Let's see, a P, our principal amount, is going to be $5,000. That's the principal investment. What's next? N is the number of compounds per year. So that's going to change. Maybe I'll come down here. Annual means that N is going to equal 1. We're going to calculate the interest once per year. Semi-annually, N will equal 2. So we're going to calculate interest twice a year. Quarterly, we're going to calculate interest 4 times in a year. And monthly, there are 12 months in a year, so interest will be calculated. This is our number of compounding periods. We're going to do that 12 times in a year. All right, let's see. R, I skipped over R. R is the interest rate, which is 4%, but as a decimal, so 0.04. And then T is our time in years, and in this example, we are talking 3 years. Okay, so we just want to compare, if this is our situation, would it be better to have the interest compounded annually or semi-annually, quarterly, monthly? Let's just kind of see how this plays out when we plug these values into our formula. So formula A equals P 5,000 times 1 plus our rate, 0.04, divided by N. For this example, N is 1. We're going to raise it to the N times T power. So 1 times 3. And then we will calculate this. So what I want you to do is grab your calculator and try this out, see what you get, see if you get this answer. $5,624.32. If you're not able to get that answer with your calculator, then you need to figure out how to type this into your calculator. All right, so we want to be careful, but I want you to check your calculator skills. Can you type this in okay? All right, let's see. Why don't we do N equals 2? So A equals, well, what if we calculate our interest twice a year, if we have 2 compounding periods in a year? So we have A equals 5,000 times 1 plus 0.04 divided by 2 raised to the 2 times 3 power. So that 2 times 3 means that we will end up compounding interest 6 times total if we do it twice a year for 3 years. All right, so type that into your calculator. Tell me if you get this answer. Okay, so it's the same situation, it's the same amount of money, but if we calculate interest twice a year, your value of your account is more after 3 years. So that's kind of cool. All right, what if we calculate the interest 4 times a year? So A equals 5,000 times 1 plus 0.04 divided by 4 times 4 times 3. Again, check your calculator skills. Can you type that in and get $5,634.36? Then our last one, monthly. So if you notice, the more times we are compounding in a year, our total value of our investment is going up. We're earning more interest. And ultimately, isn't that what we want to do? The more interest we earn, then the more money we get, right? All right, so last one, 5,000 times 1 plus 0.04 divided by 12 this time, raised to the 12 times 3 power. Check to see if you get $5,636.36. So what we notice is the more compounds per year, the more value the account is worth more. Why am I saying that weird? All right, so let's write that out. As the number of compounding periods increases, the amount in the account also increases.